Section 3.5, Derivatives of Trig Functions. You will learn that many things in biology and nature observe periodic relationships. An example of this would be heart rhythms, ocean tides, and earthquakes. When studying trig, we learned that the functions sine and cosine are periodic, so it would make sense that the derivatives would also be periodic. In an earlier lesson, we looked at the graph of the derivative of sine and got cosine. So from that, we get d dx of sine of x equals cosine of x. Here's the graph of sine of x. Now if I graph the derivative of sine of x, I get this red graph here. So now let's take a minute and just look at this red graph. Well, this kind of looks like cosine. So if I graph cosine, I see that it is perfectly cosine of x. So now what I'm going to do is I'm going to graph the derivative of cosine. And so this kind of looks like sine because it crosses at 0, 0. But it doesn't go up first, it goes down first. And so if we compare these two graphs to sine of x, it looks like we can just flip it over the x-axis. This means that the derivative of cosine of x is negative sine of x. Now what we're going to do is we're going to take the derivative of negative sine of x. So if we look at this graph and compare it to cosine, it looks like it's just cosine flipped over the x-axis. So the derivative of negative sine is negative cosine. And now if we take the derivative of negative cosine, we get our sine of x back again. So sine and cosine have a relationship that when you take the derivative, they end up repeating periodically. So if we continue the pattern, we get that the derivative of cosine of x is negative sine of x. And if I take the derivative of this, the way to do it algebraically is to take this negative and bring it out to the front. So I get negative d dx sine of x. And we just said that the derivative of sine of x is cosine, so we get negative cosine of x. And if we continue this pattern and bring out the negative, you get that the derivative of negative cosine is negative d dx cosine of x. So this becomes negative times negative sine of x, which is just sine of x. And so what we get is what I like to call the circle of sines. So the derivative, so this green arrow represents the derivative, and we get d dx. So the derivative of sine of x is cosine. The derivative of cosine is negative sine. The derivative of negative sine is negative cosine. And then the derivative of negative cosine is back to sine. This is something you're going to have to memorize. And now what I want to do is to prove that the derivative of sine of x equals cosine of x, because you don't have to take my word for it or the graph. We can do it algebraically. So recall what the definition of a derivative is. We get that d dx is equal to the limit as h approaches 0 of f of x plus h minus f of x all divided by h. And so this becomes the limit as h approaches 0 of sine of x plus h minus sine of x all over h. And from here we're going to have to use an identity. And so this is a sum identity for sine. So then we get, this becomes the limit as h approaches 0 of sine of x cosine h plus sine of h cosine x minus sine of x all over h. I'm going to rearrange my terms a little bit. I'm going to write this as the limit as h approaches 0 of sine of x cosine h. And I'm going to bring this sine of x and I'm going to put it in the middle. So negative sine of x plus sine of h cosine x all divided by h. So notice that I have a sine of x here and a sine of x here. So I get that this is the limit as h approaches 0 of sine of x, then a parentheses, cosine h minus 1 plus sine of h cosine x all over h. And then I'm going to break these up. I'm going to write this is the limit as h approaches 0 of sine of x cosine h minus 1 all over h plus the limit as h approaches 0 of sine of h cosine x all over h. Now recall that if you have sine of h over h, it's h goes to 0, then this whole piece is going to go to 1. And then this piece here, as h approaches 0, goes to 0. And we'll look at a graph to see how that works. And so this is the graph of cosine x minus 1 over x. So if we look around 0, we can see that the y value here is 0. So 0 times sine of x is just going to give me 0. So I get 0 plus 1 times cosine of x, which is just cosine x. So this is the algebraic proof that the derivative of sine is cosine. And so this is what you're going to want to go ahead and write down. That the derivative of sine is cosine, the derivative of cosine is negative sine, the derivative of negative sine is negative cosine, and the derivative of negative cosine is sine.